This brief presentation will introduce you to some ideas and experiments that a number of us here at the Sussex Humanities Lab have undertaken over the past year. So since we are an interdisciplinary or indeed transdisciplinary team, we have unique access to varied expertise and skills that enable us to carry out experiments in an agile and proficient manner. One of these experiments was, or is, using music information retrieval techniques on oral history collections. So in essence, it will pick up on some of the things that Jane and Tim have touched upon in their presentations. So this presentation will run through, as an experiment, we'll run through the hypothesis, the experiment, the results, and then this idea of repetition as well. So we started with the hypothesis that since oral history interviews in their natural or original state are audio files, that applying music information retrieval techniques, that is pattern recognition, feature extraction and clustering, would enable us to explore oral history collections differently, adding value not only to those collections but also influence the application of MIR technologies to wider fields. The hypothesis then is influenced by three strands within the lab. So that is digital archiving and digital history, which Tim, myself and another co-author, James Baker, are part of. And that brings together experience and expertise in dealing with oral history collections. And the second strand, which Chris and Alice are a part of, is the digital performance and technology, which brings that expertise in MIR and machine learning. And last but not least, to mention Ben Jackson as well, who was also part of this team, who kind of straddles across these strands and brings experience in digital archiving as well as informatics. So it was this cross-collaboration then that allowed us to kind of think about this hypothesis and how we might apply it. So our problem statement then comes from the perspective of the digital archive and history strand. And we wanted to explore the known problem, although some people might not perhaps see this as a problem, within oral history of creating text surrogates of audio files and basing subsequent analysis either through manual or computational means on these text versions. So text encodings or transcripts of oral history interviews have their obvious advantages. They are easier to anonymize, distribute and store, and they are established technique for text and/or data analysis. But as a consequence of this privileging of the text, a significant proportion of the digital resources and tools available for oral history interviews and collections do not support any analysis of the original audio associated with these interviews. Instead, they focus on things like creating oral history interviews using digital recording devices, how to manage these files, and how to create transcripts using audio to text tools. Although manual transcriptions is still a predominant method in this field. While using text surrogates is an embedded tradition, the community is slowly beginning to question the privilege of this text-based approach, given the ever-increasing possibility for computational analysis of audio. For example, MIR. And this is also evident, for example, in the UK's Oral History Society's 2016 conference call for papers, which stated the auditory dimension of oral history has for decades been notoriously underused. So while this slow move is welcome, it is true that there are few means for humanists interested in accessing and analysing spoken word collections to use and to understand how this advanced technologies for analysing sound. Even though, for example, this type of technology can resolve some of the backlog in archives and libraries of undescribed, though digitised audio collections. Of course, there are many other opportunities within that. So it is in light of this context that we wanted to explore oral history interviews and collections in their original form, and the field of MIR provided us with this chance. Alice, are your words? So MIR, okay. So MIR draws from digital audio signal processing, pattern recognition, psychology of perception, software system design, and machine learning to develop algorithms that enable computers to listen to abstract high-level musical information from low-level audio data. So just as human listeners can recognize pitch, tempo, chords, genre, song, song structure, etc., MIR algorithms are capable of recognizing and extracting this information, enabling systems to perform extensive sorting, searching, music recommendation, metadata generation, transcription on large data sets. Well done, Alice. So what we did then, okay, so it is based upon these capabilities, we started to think about possible use cases or uses. So within this kind of experimentation, we thought about kind of 3 contexts for this. So we thought about the object file, the content itself, and then the context in which that object was created. So some of these are just kind of our initial thought process around the types of things we might be able to do. So for the file or the object itself, what metadata can we automatically extract from the audio file? How can these features enhance what we already know about an object? So can these be saved alongside the object to help with search and discoverability, as mentioned previously? What are the technical specifications that we can extract from that audio file? And again, how can that kind of provide additional metadata to that archive? Also, in terms of the object, the content, what type of content analysis can we carry out? So the second context was about the content. So, for example, what type of content analysis can we carry out? So could we identify emotion in the audio stream? So extract or detect prosodic features, so for example, pitch and rhythm, that would indicate maybe a change in the audio and would identify moments of, heightened emotion. We also thought about the relationship or the dynamics between the interviewer and the interviewee. So, for example, is there overlap and interruption? Can we identify that in the audio, and does that indicate something about that relationship between the 2 people in that interview? Automatic clustering of related audio, extracting entities from the audio, comparing audio files to extract common patterns, and then thinking about extra semantic content as well. The third context was the context itself. So where was the interview carried out? Were there additional things that we could identify, like environmental features? Could these be extracted? And all of these things we thought about at scale. So it wasn't just about maybe one interview, but we were thinking about these interviews at scale to resolve archival problems where there's undescribed objects. And the mechanism that we used for these was to date 2 workshops, which used Jupyter notebooks using open source libraries in Python, librosa, and matplotlib. And the context was the Resistance Archive oral history collection, which is based at the Keep. Probably in a box, maybe, Fiona, I don't know. Yeah. So there was a number, I'll just kind of quickly, because I have 2 minutes left. So what these notebooks allowed us to kind of think about was the preparation of these audio files, the feature extraction, and the automated methods then to extract information from that. So reading, loading, playing audio files, normalization across those files to make sure the volume was the same. Feature extraction, or the characteristics, energy, frequency, to allow us to inspect the audio. And then automated means then that was that kind of moving away from just one file to kind of large files to use machine learning to sort data to look at clustering. So that's the idea of scale that we had. And the results were, so these were the mechanism, these are the workshop, the notebook that we used. So various things like visualizing the audio in a time domain, using spectrograms then to see if we can identify the 2 speakers within that interview. And then this was the kind of, I think, one of the eureka moments that we had, that Chris really worked really hard on this to kind of, in the interview, to separate that male and female voice. And initially, this was the thing that we thought would be, well, that's simple because, female voices and male voices are distinct in that pitch. But one of the interviews that we used for the Resistance Archive, there was an 80-year-old French lady who had probably smoked for, in her entire life and had this very deep guttural voice. So when we initially did that use case, it was like, well, that doesn't make any sense. But this is the kind of automated clustering that we were able to do over a few files to kind of identify where male and female voices were. So that's kind of one of the useful things around it. The mechanisms then, the results of these was there was a steep learning curve for both the participants, I think, that were doing these workshops, and for the demonstrators, for us as well. Not only in terms of, you know, kind of speaking across the various disciplines, but actually looking at those results and actually getting something that was useful and something that we could read. How many? Less than a minute? Yeah. Finished? Okay. So with the experimentations, it was difficult to read the visual representation of the audio. It wasn't always obvious what those results were, or what it was saying to us. And as I mentioned, we also kind of learned that we should never assume. So that male and female voice, we kind of assumed something that turned out to be untrue. And it was difficult perhaps to see the value with small scale examples or experiments, and therefore we need to look at, you know, experimentation with larger collections, and that's the type of future work that we want to look at. And I've left this repeat slide blank because hopefully you might be looking at some of these things tomorrow, and we will have hopefully other opportunities to kind of test this hypothesis and experiment out. So